So in this video, we're going to go over the absolute value functions today. So our essential questions are: how do you graph absolute value functions, and how do you identify characteristics of absolute value functions and their graphs? So absolute value function is a function with some form of absolute value in it. The parent no transformations absolute value function is f of x equals the absolute value of x. And if you remember that absolute values make all numbers positive. So if we have the absolute value of a -3 in here, then that would mean that f of x is equal to 3. So the vertex of an absolute value function is the highest or lowest point on the graph, and the axis of symmetry is the vertical line that divides the graph into mirror images. In an absolute value graph, it passes through the vertex. That's the axis of symmetry does, okay? So when we're graphing an absolute value function, the graph of f of x equals the absolute value of x is shown. So basically, if you think about when we're doing this, if we were to create a table of x and y values, so when we put, for example, if we put this value right here, -3 in here, when we take the absolute value of -3, we're going to get 3, right? So that's why this is -3, 3. Then if we put 3 over here, the absolute value of 3 is also 3. So we get right there. And notice that we have this axis of symmetry right here. That's what this is, okay? This is our axis of symmetry. So everything on the right looks the same as the left. So all absolute values will be V-shaped graphs like this one is, and their vertex, the slope or steepness, and the direction they point can change. And we're going to talk about that in a minute, okay? So the general form of an absolute value function is y equals plus or minus a, absolute value of x minus h plus k. Now we're going to talk about what each of these mean. Hopefully you recall that the sign out front determines if there's a reflection over the x-axis. So if it's negative, then there is a reflection over the x-axis. Our a, wow, why did it go twice? Okay, so a is the slope or stretch. It's the slope, and it's the stretch or shrink. So basically when we start graphing these, we're going to use a as our slope, rise over run, okay? And then if a is greater than 1, it's going to be a vertical stretch. And if a is between 0 and 1, which means a decimal or a fraction, then it's going to be a vertical shrink. Then we're going to talk about h. So I don't know why this thing is going more than one, y'all, but so h is a horizontal shift. This is what h has always been. So it's going to go left or right. And remember, you're always going to pull out the opposite sign. So if h, so let's say we had a -2 there, then it's going to be 2, which means it's going to be 2 to the right. If it was +2, it would be 2 to the left because it's a -2. We're always going to change the sign of whatever's there. So the next one is k, and k is a vertical shift. So this is up or down, and the sign determines the direction up or down, okay? Then we're going to pull h and k, and h and k are going to be our vertex. So we're going to pull this h here and this k there, and that's going to be the vertex, which remember is like the point of the V. So it's either the bottom or the top, depending on whether the graph opens up or down. So in our first example, it says write an equation for the following graphs and identify the intercept zeros and intervals of increase and decrease. Compare the graph with the graph of y is equal to the absolute value of x, and that's what the transformations are going to be. So the first thing we're going to do is we're going to look at this graph, and we're going to pull our vertex from this graph, okay? So I'm going to go down here, and I'm going to put where the vertex is. It's right there. So that point is -2, and then we're going down 1, 2, 3. So that's -3. So that's our vertex. Now, when we're talking about a, first of all, a would be positive if the graph opens up, and this one does. A would be negative if the graph opens down. But you can also do this by just getting the slope. So the way that we find the slope is we do rise. So we're going to find 2 points on the line. So I'm going to use this point and this point because they're on the right side of this graph. And so I'm going to go up 1, so that's my rise, and I'm going to go over 2, that's my run, right? So that's my slope. Now we can write the equation, okay? So when we write our equation, we're going to say y equals, remember it's a, that's my 1/2, absolute value of x minus h, so that's minus a -2, plus k, which would be -3. So I'm actually just going to put a -3 there, okay? So when we write our final equation, it's going to be y equals 1/2 absolute value of x plus 2 minus 3. Okay, that's the equation. Now, we can't see the intercepts on this graph, not all of them. We can see the y-intercept, but we cannot see the x-intercepts. So to solve for the x-intercepts, what we're going to do is we're going to put 0 in for y and solve for x. So we're going to use this equation we just found right up here. We're going to use this equation right here, and we're going to solve for our x-intercept, okay? So x-intercepts, there's going to be 2 of them. And we can tell that if you're looking at the graph here, can you tell if it's going up here to the right, it's going to intercept the x-axis over here somewhere and over there somewhere, okay? So we're going to put 0 in for y and solve for x. So we're going to say 1/2 absolute value of x plus 2 minus 3. So when I do this, I'm going to add 3 to both sides. So when I do that, I get 3 equals 1/2 absolute value of x plus 2. Then I'm going to multiply both sides by 2 to get rid of that 1/2. Okay, so that's going to leave me with 6 equals the absolute value of x plus 2. Now this is where you're going to switch this up. So you're going to solve for both a 6 and a -6. And the reason I'm doing that is because obviously the absolute value means that if there was a negative value in there, then it would become positive, okay? So we're going to solve for this +6 first. So when we do that, we're going to actually subtract 2 from both sides. So that means 4 equals x. But then we're also going to solve for a -6. And this is how you always solve for absolute value equations. So this is still going to be x plus 2. So we're going to again subtract 2 from both sides. Move this other way. And so then that's going to be -8 is equal to x. So these are our x-intercepts. So that means that we've got 4, 0, right? And then we've got -8, 0. Those are our x-intercepts, which those are also our zeros. So we can say x equals 4 and x equals -8, okay? Now, we're also going to solve for our y-intercept. And when we do that, we're going to put 0 in. Now, we can see it right here, can't we? It is -2, but I want to show you how to solve it because you're not always going to be able to see it. So once again, we're going to use our equation. And when we do the equation this time, we're just going to say y is equal to 1/2, and we're going to put 0 in for x, okay? So once again, we're going to do just what's on the right. So this time we got 1/2, and 0 plus 2 is the absolute value of 2, minus 3, right? And then, let me see if I can get down here a little further so we have a little more space to work with. And so then this is going to be 1/2 times 2, because the absolute value of 2 is 2. That's minus 3. So this is going to be 1/2 of 2. That's 1 minus 3. So that's going to be equal to -2. So, and that's exactly what we saw up here on the graph, right? So isn't this at -2? So that's my other intercept. So this one is going to be 0, -2, okay? Now sometimes you'll be able to see all these intercepts on the graph and be able to pull them from there, but I like to check because sometimes they're not exact. All right, now we're going to talk about intervals of increase and decrease, okay? So as we're looking at this graph and we're coming in from the left, what's happening? Is the graph going down or up? Okay, so this is -infinity over here, remember, and this is +infinity. And when we're talking about intervals of increase and decrease, we're talking about the x values, okay? So from here to here, and this is what value? This was -2, right? So what values do we have there? And what's happening? The graph is decreasing, and it's decreasing from where? -infinity to -2, right? Now let's look at where does it increase from. So from there on, it's increasing, right? So where is that? That's -2 to where again? To infinity, okay? So it's increasing from -2 to infinity. Now, when we're talking about transformations, we're talking about comparing the graph that we have right now. So I'm going to actually erase all this, and we're going to just talk about this graph, maybe, if it will let me. There. We're going to talk about this graph, and we're going to compare it with just the graph that is the absolute value of y. The absolute value of x, okay? So that's my original graph. How does it compare? So we want to look at A. And what did A tell us? If we went back, we would say that A has to do with a shrink or a stretch, right? And remember, if A is between 0 and 1, it's a shrink. So this is a vertical shrink by a factor of what? By 1/2, okay? Then what do H and K tell us? Okay, so let me go back up here. And we can look at the graph, or we can look at this right here, right? So notice here that the graph shifted 1, 2 to the left, didn't it? Okay, so it goes left 2. And how much did it shift down? 1, 2, 3. So it went down 3. And everybody look up here a sec. So basically, notice here, that means that's a -2, right? So that would mean it goes left 2, and this was a -3, so that's why it went down 3. And here was our 1/2, and that's why we could say it was a vertical shrink by 1/2, okay? So let's go on to the next one. So here again it says write an equation for the following graphs and identify the intercepts, zeros, and intervals of increase and decrease. Compare the graph with the graph of y is equal to the absolute value of x. Go ahead and try and do this one. Pause the video and come back to me when you're done. Okay, here again, I'm going to look at the vertex of this graph, okay? So right here's our vertex. So that's going to be 1, 2, 1, 2, 3. So I'm going to say 2, 3. When we're trying to find A, now I notice that this graph opens down. So that means I know for sure that A is going to be negative. But even if I didn't, I could just measure the slope. So I'm going to, again, look at 2 places where the graph intersects. And I'm going to go 1, 2 down. That would be a -2, and it's 1 over, right? So that's going to give me the slope of -2, isn't it? And that's going to be my A. So now we can write our equation. So y is equal to, our A is -2, and then the absolute value of x minus 2 plus 3. This time we didn't have to change the signs of anything, okay? So on this one, it looks like we can almost tell where the intercepts are, but I like to go ahead and solve for them anyway, so that's what we're going to do. So here again, I'm going to put 0 in for my equation. So that's going to be -2, absolute value of x minus 2 plus 3. So we're going to subtract 3 from both sides. So that's going to give us -3 equals -2, absolute value of x minus 2, right? So then we're going to divide both sides by 2, -2, sorry. So that's going to give us 3 over 2 equals the absolute value of x minus 2. Now remember, here again, I said we're going to solve for a 3/2 and a -3/2. So I'm going to add 2 to both sides. So that's going to give me, that's 1.5, so that's going to be 3.5, right? Okay, and then we're also going to solve for the -3/2, okay? So that's going to be, again, the absolute value of x minus 2. So I'm going to add 2 again. So remember, -3/2 is -1.5, so that's going to be 0.5 is equal to x as well. So those are our intercepts. So we're going to say 3.5, 0, and 0.5, 0, right? And remember, those are our zeros as well. So we can say x equals 3.5 and x equals 0.5. Now we also have to solve for this one right here, although we can see it. I'm going to, again, show you how to do it because sometimes you won't be able to see it. So I need you guys to know how to do this. So on this one, we're going to say y equals, and we're going to put 0 in for x. That's going to be -2, and this is going to be 0 minus 2 plus 3, right? So this is going to be y is equal to -2, and then the absolute value of -2 plus 3. So this is going to be y equals -2 times 2, because the absolute value of -2 is +2, plus 3. So that's y is equal to -4 plus 3, which is equal to -1, which is exactly what we thought it was right there, okay? So then that intercept is going to be what? This one's going to be 0, -1, all right? Now, let's talk about our increase and decrease. So we're coming in here from the left. What's happening to the graph? It's increasing, right? And it's increasing from where? So we got -infinity over here. And what is this point right here? 2, right? So our graph is increasing from -infinity to 2. And then from 2, what's happening from there? On to infinity out here, okay? So from 2 to infinity, the graph is what? It's decreasing, right? Okay. So now let's talk about our transformations. So first of all, is this graph opening up or down? Yes, it's opening down. So we're going to say it reflects over the x-axis. We're always going to say that if the graph opens down, which is when A is negative, okay? And then this 2 right here tells us it's a vertical stretch by a factor of what? By 2, right? And then this 2 tells us that it's going right 2, and this 3 tells us it's going up 3. And remember, our original graph would have been right here, right? And it would have been, I mean, this is the absolute value of x, right? So you should be able to see that it opens down, right? So it's a vertical, it's a reflection over the x-axis. It moved 1, 2 to the right and 1, 2, 3 up. And it's narrower, right? So it's a vertical stretch, okay? All right, now we're going to talk about how to graph these now, okay? So the first thing I'm always going to do is I'm going to pull the vertex from here. So those are the numbers, right? So our vertex, remember, when we pull the h, this right here is always going to be opposite of what's there. So this is going to be a -3, and we pull the k, it's going to be exactly what it is. Then we're going to talk about this slope, okay? So, and let's look out front here. So is this positive or negative, that 2? It's positive, right? So that means this is going to open up. If it's negative, it would open down. And then our slope is always going to be a fraction. So we're going to make this 2 over 1. Now this is going to help us graph it, okay? So let's go ahead and plot our vertex first. So we're going to plot our vertex at -3, -1 right here. Now this, we know it opens up. So what we're going to do from this point is we're going to go 2 up and 1 over. Right there. And then we're going to do the reflection of that on the left. So we're going to go 2 up and 1 over here as well. And I can keep doing that so that I can make sure that my line is going to be relatively straight, right? I'm going to do it another couple times over here. So again, I can make sure it's relatively straight at least. So this is how I'm going to make a pretty accurate line freehand, okay? Keep going up 2 and over 1, okay? So there's my graph. And on this one, we can kind of see the intercepts, but we're going to have to, let's go ahead and solve for them anyway. So once again, we're going to go down here. We're going to solve for our x-intercept by saying 0 equals, and we're going to set it equal to that equation up there, 2 absolute value of x plus 3 minus 1, okay? So we're going to add 1 to both sides. So that's going to give us 1 equals 2, absolute value of x plus 3. Then we're going to divide both sides by that 2. So that's going to give us 1/2 equals the absolute value of x plus 3. Okay, now remember here again, we're going to solve for positive 1/2 and a negative 1/2. So we're going to subtract 3 from both sides of the positive 1/2. So that's going to give us -2.5 equals x. Then we're also going to solve for the negative 1/2 here. So that's going to be equal to, again, the absolute value of x plus 3. So we're going to subtract 3 from both sides. So this is going to be -3.5 equals x, okay? So those are going to be my intercepts. So I'm going to say -2.5, comma 0, and -3.5, comma 0. And those are my zeros. Remember, those are also our zeros. Okay, now we're going to solve for our y-intercept, which again, we can kind of see, it looks to me like it's at 5, but I'm going to solve it anyway just to make sure. So this time we're going to say y is equal to 2 times 0 plus 3 minus 1. So this is y is equal to 2, absolute value of 3, minus 1. So this is going to be y is equal to 2 times 3 minus 1. So y is equal to 6 minus 1, which is 5. Which is what we thought it was going to be. So this is going to be 0, comma 5. That was our y-intercept, and that's kind of what it looked like right there, okay? So now here again, we're going to talk about our intervals of increase and decrease. So we're coming from negative infinity here, and we're headed towards infinity, okay? So as we jump on the graph here, what's happening to the graph here? It's going down. So we're decreasing from where? From negative infinity to what's this point right here, y'all? Isn't that -3? Okay. And then we're going to pick it back up here, and what's happening here? Yeah, the graph is going up. So we're going to go -3 to where? Infinity. So this is increasing from -3 to infinity. Now I want you guys to notice, hopefully you've seen this by now, that these numbers repeat themselves here. Do y'all notice that? So that's one of those things that you need to pick up. And do you also notice that that has been our H every time? Okay. So I want you guys to see it a couple times so you could kind of see the pattern. Notice that that is the number that's right here. Okay. And it should be, because that was a -3. So it is this value, the H value of our vertex. Okay. Now let's talk about our transformation. So let's look at A. I'm going to erase this here. So we're going to look at this first. So what does that tell us? So this is a vertical stretch by what? By 2. Okay. And then what does this right here tell us? It went left 3. And then what about this right here? What does that tell us? Down 1. Okay. Hopefully you guys are seeing these patterns by now. Okay. All right, let's see if you guys can do this last one. Come back to me when you're done. Okay, so on this one, again, I'm going to pull the vertex first. That's just kind of what I like to do. So I'm going to look at this value and this value. So this vertex is going to be 5, 6. How did this open? That has to do with that negative right there. So this one's going to open down because A was negative. Our slope is going to be 3 over 1, or you could say -3 over 1, right? Because again, that's a -3. So when we plot this one, we know for sure it's going to open down. So our vertex is going to be at 5, 6. So I'm going to go up here and make it at 5, 6. That's our vertex right there. And then I'm going to count 1, 2, 3 down and 1 over. So that's going to be my first point right in there. Remember, it's going to be on either side, okay? So let me see if I can do this again, just so you guys can see it. So 5, 6, 1, 2, 3, down, 1 over, 1, 2, 3, down, 1 over, 1, 2, 3, 1 over, 1, 2, 3, 1 over. Okay, so right there is, and I could keep going down, 1, 2, 3, 1, oh, whoop, 1 over's there, sorry. So I can see where it intercepts. 1, 2, 3, 1 over there, 1, 2, 3, 1 over there, 1, 2, 3, 1 over there. Do y'all see that? So I'm going to go ahead and draw my graph now. And because I used that slope, my numbers are pretty accurate this time, okay? I can't draw a straight line there, y'all, but you get the drift, okay? So sometimes you can pull those intercepts from the graph, but the way you want to check them again is to plug them into the equation, okay? So I'm going to guess that my intercepts are going to be at 3, 0, and 7, 0, and down here at 0, -9. But I'm going to, because that's what I can see here. Let me show you what I mean. So notice this one right here, and this one right here, and then this one down here, okay? So I'm still going to solve for these just because I want you guys to see that, that I'm going to get the same answers, okay? So I got 0, 0 is equal to, we got a -3 absolute value of x minus 5 plus 6, right? Okay. So again, I'm going to move that 6. I'm going to subtract 6 from both sides. So that's going to give me -6 equals -3 absolute value of x minus 5. Going to divide both sides by -3. So that's going to give me 2 is equal to x minus 5, right? So remember, we're going to solve for a 2 and a -2, right? So we don't have to leave that x absolute value there once we get there. So we're going to add 5 to this side. So that's x equals 7. That was the one that we thought was right there, right? And then we're going to add 5 to this side. So that's going to give us 3 is equal to x. And that was our other one right here, okay? Now remember, with our y-intercept, we're going to solve for, by putting 0 in for x, okay? So this is going to be y is equal to -3, 0 minus 5, plus 6. So we're going to, this is negative 3, and this is the absolute value of negative 5 plus 6. So this is going to be negative 3 times 5, right? Because the absolute value of negative 5 is 5 plus 6. So that's going to be negative 15 plus 6 equals y. So y is going to be equal to negative 9, which is exactly what we thought it was right here, okay? So remember again, our zeros are, our zeros are going to be x equals the 3 up there and x equals 7. So now let's look at our graph again and see if we can figure out where it's increasing and decreasing, okay? So I'm going to jump on my graph from the left here, and I'm going to go, where am I going? I'm going up, right? So that's an interval of increase, and where does it increase to? This 5, right? So we're going to say it increases from negative infinity to 5. And remember, I said we're going to pick it up right by that 5, and we're going to go on to infinity, right? So now what is happening to the graph here? Notice it's going down, right? So it's decreasing from 5 to positive infinity. And remember again, these numbers are repeating themselves, okay? So now let's talk about our transformations. So we're going to look back up here at this equation. So notice that it's negative up here, okay? So when it's negative, what does that tell us? It's a reflection over the x-axis. So we're going to say it reflects over the x-axis. What did the 3 tell us? It's a vertical stretch by 3. And what did this 5 and this 6 tell us? So then it went right 5 and up 6.